In this video, I am going to describe the demo dimmer example of KAIStack, which located in APPL example folder. Demo dimmer example simulates a dimmer system, a series of buttons to control the luminance of lamps. This example contains 3 channels, channel 1, channel 2, channel 3, which any of them performs a specific duty and operation. In this picture, we take a look at the operation of push buttons, sensor buttons, which is used in a dimmer system. By pressing a start stop push button, this is a start stop push button in channel 1, dimmer turns on the lamp gradually and then turns off that lamp gradually after a while. By pressing up button from channel 2, for a short period of time, dimmer turns on the lamp, but if pressing this button takes for a long time, the dimmer will increase the luminance of lamp. By pressing down button for a short period of time, dimmer turns off the lamp, but if pressing this button takes for a long time, then dimmer will decrease the luminance of the lamp. By pressing set button, dimmer sets the luminance of the lamp with a specific value, a number between 0 and 256. And in channel 3 we have a lamp, it's dimmer. Okay. To recognize these buttons, we can use 2 methods, first method and second method. In the first method, pressing a button triggers an event which determines the pressed button in app sensor event, and also stores the related data in app sensor's event data. So we have a app sensor event and also app push button timed event for the start stop button and app sensor event data. In the second method, SC event 100 ms event happens every 100 milliseconds and calls get push buttons to check the status of buttons. Demo dimmer example applies this method to recognize the press button, and I will describe it later. These state machines indicate a process cycle of event handler for the first method. First method I described here. By pressing a start stop button, our push button timed event gets pressed. In this case, event handler sends COCH1 timed start stop communication objects with proper value to enforce the dimmer to perform start stop operation. Also, by pressing sensor buttons, app sensor event gets a proper status. One of this status, and based on status, handler sends related communication object with proper value to enforce dimmer, to perform a proper operation like switching on or off, dimming the lights, or change the luminance of the lamp with a specific number. After sending the related communication object to the KNX network, the status of sensor become app idle to be ready for next incoming event and avoid unwanted behavior. Another view of communication objects which are sent to KNX network is indicated in this picture with more details. On channel 1, by pressing a start a stop button, event pressed happens, and then a COCH1 timed start stop communication object which its value is equal 1 is sent to KNX network to enforce dimmer to perform a start stop operation. On channel 2, by pressing up button for a short period of time, COCH2 switch communication object which its value is on or 1 is sent to KNX network to enforce dimmer to turn on the lamp, but if up button has been pressing for a long time, COCH2 dimming communication object with a specified value for steps is sent to KNX network to enforce dimmer to increase the luminance of the lamp. By pressing down button for a short period of time, COCH2 switch communication object which its value is off or 0 is sent to KNX network to enforce dimmer to turn off the lamp, but if down button has been pressing for long time, COCH2 dimming communication object with a specified value for steps is sent to KNX network to enforce dimmer to decrease the luminance of the lamp. By pressing set button, COCH2 value communication object which its value is a number between 0 and 256 is sent to KNX network to enforce the dimmer to change the luminance of lamp to this specified number or a specified value. On the other hand, on channel 3, the dimmer receives the communication objects from KNX network and keep them in actor 1. Actor 1 is an object from dimmer objects class or dimmer objects structure. The dimmer evaluated received communication object to do the related operation to switch on or off the lamp, dimming the lamp, or change the luminance of lamp with new value for set point. Finally, dimmer returns the status of itself to the KNX network to notify buttons and sensors, but sensors about its value. So there is a feedback path here. In this picture, I have indicated the buttons on KAIStack evaluation board, which operate as start-stop buttons and sensor buttons. These buttons are managed in get-push button every 100 milliseconds by the SC event 100 MS event. And this is the method which is actually used in demo dimmer example. B0 acts like a down button. So by pressing B0 for a short period of time, COCH2 switch communication object, which its value is off, is sent to KNX network to enforce dimmer to turn off the lamp. But if B0 has been pressing for a long time, and COCH2 dimming value, space communication object with a specified value for a step is sent to KNX network to enforce dimmer to decrease the luminance of the lamp. By pressing B0 after a long time, dimming will stop. B1 acts like an up button. So by pressing B1 for a short period of time, COCH2 switch communication object, which its value is on, is sent to KNX network to enforce dimmer to turn on the lamp. But if B1 has been pressing for a long time, a COCH2 dimming communication object with a specified value for a step is sent to KNX network to enforce dimmer to increase the luminance of the lamp. By releasing B1 after a long time, dimming will stop. B2 acts like a start-stop button. By pressing B2, COCH1 time the start-stop communication object, which its value is 1, is sent to KNX network to enforce dimmer to perform a start-stop operation. In other words, to turn on the lamp gradually and then turn it off gradually after a few seconds. B3 acts like a set button. By pressing B3, COCH2 value communication object, which its value is a number between 0 and 256, is sent to KNX network to enforce the dimmer to change the luminance of lamp to this specific value. Since there is no lamp on KAIStack evaluation board, the example has used LEDs to simulate a lamp and its related luminance. The more luminance the virtual lamp has, the more LEDs will be on. For example, when the luminance is 0 or the virtual lamp is considered off, then none of the LEDs are on. All of them are off. When the luminance is 256 or the virtual lamp is considered on, then all 8 LEDs are on. All of them are on. When the luminance is a number between 0 and 256, like 100, only a few LEDs, here 3 LEDs, are on. To convert a number between 0 and 256 to the range between 0 and 8, you only need to divide it by 32. In this picture, I describe the structures and the components of the dimmer example. Setting of dimmer is kept in this variable, which has been made from dimmer setting structure. There are 2 user timers in this project, which has been defined in app.h header file. These timers are TM actor 1 to make a gap between dimming operation to make dimming gradually, and the second TM actor delay. In a start-stop operation, lamp is on at first, and after a delay which is made by this timer, the lamp will be turned off. Timer NR points to TM actor 1 to control dimming operation. There are 2 parameters which have been defined in app.h. Dim time, which determines time interval for TM actor 1 timer, and dim to value, which determines if defining to a specific set point must be done gradually or immediately. For example, if it's on, then turning on and turning off happens gradually. But if dim to value is off, then it jump to that value. There is no gradual change in luminance of the lamp. And also some easy parameters like CH3 time duration, which determines time interval for TM actor delay timer. Parameter pointer points to parameter, as you can see here. Communication objects table has been defined in codetape.h. All 3 channels, channel 1, channel 2, and channel 3, have their specific communication objects in this table. Channels 3 communication objects starts from here, which OBG base number from setting points to this entry. I indicated this here. OBG base number points to this entry, this over here. Okay. AppRam in app.h contains the variables which keep the value for all communication objects of 3 channels. Communication objects of channel 3 are kept in actor 1, which has been made of dimmer objects. Object variable points to this variable or struct. So actor 1 is a middle between channel 3 and the outside world. Finally, data variable from dimmer data is considered to save the setting of dimmer, like new set point or current value or state of dimming, and return back value to sensors or to network. In channel 3, the received communication objects are kept in actor 1 at first. Then they are loaded into data variable to perform dimmer setting. Also, to return back the dimmer value to sensors, they are copied to actor 1 at first. Then they are passed to KAIStack network. This picture indicates the actor 1 as a middle object between sensors and dimmers or actuators to keep traveling communication object, as I described in the previous picture. This state machine indicates the state of dimming in dimmer when it receives a communication object. As usual, idle is a start state. When dimmer receives a switch on or off, or a dimming communication object while the dimming to value parameter is equal to 0, then it stays in idle and change the luminance of the lamp to the received set point immediately, jumps to that value. But when dimmer receives a start, a stop, or a dimming communication object with dim to value is not 0, or when the communication object, the received communication object has the value, dim to value is greater than 0, then it goes to dim state and try to increase or decrease the current value of luminance to new set point gradually by the time interval which is produced with TM actor 1 timer. TM actor 1 timer for a specific time try to reaches the current value, reaches the current value to the set point. When current value of dimmer reaches to the new set point, when it reaches to this new set point, the state goes back to the idle again from this path. To return the value of dimmer to the sensors, we insert the current value to a state value, then determine if switch is on off. Finally, by giving the value to the last sent value, we will remember that if we have sent back the last status of dimmer to sensors or not. In this case, we send CH3 state value to the KAIStack. To return the switch status of dimmer to the sensors, we insert the current value to the state value, then determine if switch is on or off, and insert this value to the state switch. Finally, by giving this on-off value to the last send switch variable, we will remember that if we have sent back the last status of dimmer to sensors or not. In this case, we send COCH3 state switch to the KNX network.